Hi everyone, my name is Kantoma. I'm from GREYTEST Design Concept. This is actually my WhatsApp contact. You can reach me on this number, or you can call me, okay? These are the list of softwares which I've covered on our YouTube channel. They are very much available on our Telegram platform, where we teach people how to design with each of the software, guide you on how to install it and how to crack it on your system itself. Okay, just for a token, okay? We have covered a very wide range of design on structural designs and detailing, on road designs, on water designs, on electrical and mechanical service drawings and architectural working drawings. All are very much available on our YouTube channel. Down below the description of this video, you will find the link to that channel. Why not go there and actually keep yourself busy? Today I'm going to be showing you how to design your pile foundation, okay, using Protastructure. Okay, let's jump right into it. This is our Prota detail. Okay, on our Prota detail, I'm going to click on new project and I'm going to name this pile foundation. Okay, good. Now I'm going to click on OK. DS8110. Okay. Right, good. Now I'm going to start by creating a new drawing. I'll click on that. I have covered a very wide range of design on Prota detail, staircase, pile cap, okay, retrofit, pit foundation, shear wall, isolated this part footing detail. I have covered all of that on this YouTube channel. Okay, you can just find the link to that channel on the description box. You can follow me on any of those social media platforms down below the description of this video, and then actually and then we can chat out from there. Okay, I'm going to my pile. Okay, as you can see here, this is pile design. Okay, I click on that. Now this is the pile geometry. I'm going to leave it as P1. okay, the circular pipe which I'm going to pile rather, which I'm going to leave it as it is. Okay, but I can click down here, I can make it square, I can make it rectangular, but I'm going to leave it circular. Okay, pile type, is it board, is it pre-stressed? Okay, I'm going to leave it as board. Okay, stirrup type, this is circular. Okay, I can make it spiral. The pile length, okay, this is our penetration, which I'm going to make it 600. okay, my reference level, I'm going to make it 1000. okay, so it's going to be minus 1000. Good. My concrete cover, I'm going to make that 50. okay, all right. Now the pile length, okay, from our soil analysis, okay, is actually going to be at 50 feet, okay, depth. Okay, 50 feet, that is 15 meters, okay, which is going to be 15000. okay, that will be our pile length. Okay, this is actually from analysis, okay, our soil report. Okay, so I'm going to be maintaining that here. Okay, now I'll go to my design. I'll check on working load. Now the axial force here, let's check that from here. Okay, good. Now the diameter, this is actually an analysis. Okay, report, which I actually took, and I'm actually going to be using that right now. You can see the diameter of the pile is actually 20 inches. You can convert that to millimeters, that's in metric units or in meters. Okay, the length of the pipe, which is pile rather, which is 50 feet. Okay, the capacity of the pile, so each one of those pile is actually 75 kg. Okay, now the total reaction is 185. Now the load with pile cap, okay, the total loading is basically going to be 203.5. now if you divide this by 3, that's the number of the pile that is required is 3. Okay, if you divide it by that, you're going to be having 67.83. now approximately, which is actually 70 here, so we have 70 kg. Okay, now if you look at this, we have 1 kilonewton is actually equivalent to 0.225 kg. Okay, so if you do that if you actually calculate that, you discover that 70 kg will actually give you 311.1 kilonewton. Okay, so which I'm going to be approximately using 312. Okay, good. Now the pile spacing. Okay, good. Now I'm coming back here, which I'm going to be using 312 as my axial force. Okay, now if you come down here, you can see the rebar material is actually 460. Okay, and then the concrete material is actually 225/30. Okay, so these are actually the characteristic strength of concrete. You can switch that here to suit whatever you want. You can see if I switch this here, you will discover the modulus of elasticity will actually change. So this is by default. Okay, this is actually a template based on BS8110. Okay, so this is actually, so you need not to actually tamper with any value that is here, except you have any special design which you want to actually achieve. Now, but if that is correct, the next thing you do, rebar diameters. Okay, you can change the size of your reinforcement here. This reinforcement, I can change this to 20, and then the diameter for my links, I'm going to make that Y10. Okay, you can see the spacing here for 200 spacing. This is actually going to be 110 spacing Okay, you can see the quantity of longitudinal reinforcement that will be there will be 15. Okay, so I'm going to leave everything as it is right now. I can reselect the reinforcement bars. Okay, which everything here is actually perfectly okay as I want it. Okay, you can see the working load calculation must be done. Okay, okay. Okay. Okay, let's go to our soil profile. Coming back here, you can see it's actually the interval of depth interval. Okay, from our soil result here, which I'm going to take this back to. Okay, it's actually at you can see actually at 5 feet, which is the same thing as 1.5 in meters. Okay, so I'm going to leave it as 1.5, which is 15 1500 millimeters, okay, which is okay here. And then the type of soil, okay, which I'm going to, from our results here, sorry, it's actually not very clear, but we have the first soil here, we have sand. The second one here, we have our okay, we have our stiffy clay, okay, which I'm going to switch this to, sorry, rename this, here is sand. So here we have stiffy clay, okay. Sorry, I'm going to add a new type of soil, stiffy clay. So this is actually from the soil analysis. So whatever you get from there, from your report, which because of time I may not be inputting all of those values as it is, but whatever value you have from your results, you insert them, you input them here, okay. You can see the internal friction angle, the undrained shear strength, okay. From these are all soil reports. So but because of my time, I'm actually going to, I just want to make this design as brief as possible, okay. I'm going to leave it as stiffy clay. I'm going to leave this as it is right now, okay. Click on OK, close. Sorry, that didn't stiffy. Okay, so I'm going to make it same for all of this, because all this soil here we have actually different type of our stiffy clay, okay. So they are all clay, stiffy clay, different type of stiffy clay that we actually have here. These are actually in layers, okay. So at 1.5, 1.45 layer, that is the type of soil we have here from our soil report, okay. So I'm actually going to be using stiffy clay, okay. Now sorry, I have actually passed 1.5, so I'm going to make these seals, and I click on OK. So you can see at 15 meters, okay, we have stiffy clay, okay. So you can see it here, this is 5 meters, this is 10 meters, this is 15 meters, okay. So at each of this layer 1.5, okay, this is actually the properties of the soil that we actually have at each of this layer. We tend to have stiffy clay at each interval at this point. Here we have a sand, here we have stiffy clay at 1.5, okay. So you actually have to use the soil reports. You get from the soil test. Okay, come down to our working load, the spacing in diameter. Okay, so so this is actually 3 times the diameter. So the number of the columns, sorry, the number of piles. Okay, we have 3 number of piles. Okay, so which I'm going to leave as it is. So the number of columns that is actually coming on top of your pile, okay, it's actually 2, which I'm going to actually leave all of this as it is. Okay, the efficiency factor, I'm going to leave that. Okay, I'm going to leave all of this as it is. Okay, so this is actually the provided area of steel. Okay, okay. So this is our standard penetration test. Okay, so I'm going to use the one we got from our report. Okay, if you look at this here, we have 25911. Okay, 25911, 25911. Okay, so come down here, 25911, 15967 1010, 15967 1010, 15 9 6 7 10 10. Okay, 10 10. Okay, then we have 2630. Okay, 2630. All right, good. So if you already love what you're seeing, why not give it a thumbs up? Like this video, make sure you give it a thumbs up. Okay, click on the bell icon so as to always get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Okay, so make sure that you actually subscribe. You see a red button down below, and click on that button and you have subscribed already. It's actually 100% free. Okay, there is no service, okay, attached. There is no charges attached to that. Okay, so this is our working load. You can see it says working load calculation must be done. So I'm going to calculate working load right now. Once you click on that, now you can see now it has turned green. It's telling me that our working load calculations are done. Okay, and it's actually showing me green. Okay, now the working load is actually 410. If you remember from our design here, we have 310 as our axial force. Okay, which is actually lower than our working load, which is perfectly okay. Okay, if you come back here, it's actually lower than this, so this value is actually greater than our axial force. Okay, so which is okay. Now now you can see this is actually the diagram from this graph that you can see here. Come down to our design summary. This is the summary of our design in total. Okay, you can see our pile label, pile diameter, pile length. Okay, pile spacing. Okay, 3 times the dimension, the pile column number. Okay, and then the pile row number. Okay, now I'm going to leave this as it is, and then I'll click on sorry, let me see this. I'm going to add the quantity table to drawing. I'll click on my reports. this is my report. So this actually can be printed. I can convert this to PDF. I can make it in Microsoft Word and do whatever editing I want to. I may want to change any value that is actually here. Okay, now I close that. Okay, then I click on OK. Now this is my lean thin my lean concrete thickness. Okay, so this is actually 100 here. I can actually reduce that to whatever value I feel it suits my design. Okay, I click anywhere on the window and then my design is actually very much ready. Now this is my pile foundation. Now if you love what you're seeing, make sure that you give it a thumbs up. Like this video, give it a thumbs up. Subscribe to this channel, it's actually free. Click on the bell icon so as to always get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Make sure that you stay safe and make sure that you actually stay blessed. Okay.